This change passes every unit test. But under real concurrent traffic, more than 94% of requests fail. Concurrency, latency, and dependency regressions often remain invisible until production. Reproducing realistic load and correlating the server-side evidence still takes too much manual work. TraceForge automates the full release proof loop. It inspects the change, generates a deterministic K6 experiment, reads traces and logs through SigNoz, writes a minimal fix, and reruns the identical test to prove the result. First, TraceForge establishes a healthy baseline from the unchanged revision. The candidate appears faster at the tail, but that number is deceptive. Failed lock requests return quickly. The decisive signal is the failure rate, 94.4% at the client, with 3,158 server-side error spans. TraceForge queries the exact experiment window through SigNoz MCP. The status distribution inverts, lock errors spike, and the correlated traces point to post/API/visits. The release proof projection finds 154 correlated lock error logs in the candidate phase and 0 after the patch. The root cause is specific and reviewable. The candidate holds an immediate SQLite write lock during simulated work while allowing only a 10 millisecond busy timeout. TraceForge generates the smallest relevant patch. A separate audit verifies the telemetry grounding, patch scope, reversibility, tests, and safety before the change is applied. The patch runs only inside an isolated sandbox. TraceForge executes the identical experiment again. Failures fall from 94.4% to 0.16%, lock errors disappear, and the release is marked ship. It also catches failures that never produce an error. In the silent degradation scenario, failure rate stays at 0 while P95 climbs beyond 2 seconds. TraceForge detects the latency trend and verifies a patch back below the original baseline. A harmless control change passes without an unnecessary patch. Every workflow stage and MCP call is observable in SigNoz, while the hash-chained ledger makes every transition replayable and tamper-evident. TraceForge does not guess from the diff. It runs the experiment, reads the server-side truth from SigNoz, writes the fix, and proves it.